Okay, so this will be an introduction to the calculus module. We are starting off with the concepts of derivatives and the operation of differentiation. They sound fancy, but what we're going to focus on today is basically the intuitive understanding of what these two terms mean, as they can be actually explained quite in simple terms without much mathematical jargon. And we're going to concentrate solely on this today because of how important it is for you to actually understand the basics of calculus intuitively before you move on to actually applying it and using it. Because this is a difficult module, this is a difficult part of the curriculum. It can be, you can survive it without really having lots of understanding and just basically following rules, but it'll just be survival. If you actually want to apply this, if you want to solve problems creatively, if you want to be able to apply this in real life situations, you need to be able to understand it really well. Okay, so I cropped out a part of a function of the following formula. So this is basically a polynomial, fifth order polynomial. But what we're most interested in this case, is its shape or its behavior. In other words, just think about what this function does as we read the graph, as we follow the graph from the left going to the right. In the beginning, it may sound a bit primitive when we just say, well, when we go from the left to the right, when we read this graph from the left side going to the right, we can say that the function increases, then it has a maximum, goes down, increases again, decreases again, and then increases faster and faster from when x is equal to 1, more or less. Okay, so this may sound like a primitive description. We can get into more details if we want to. We can say zoom in at this part of the function here and say, well, the rate at which the function decreases here is definitely less than the rate at which this function increases here, right? It's steeper, we can say that. We can also say that, well, starting from here, the function increases, but it increases faster and faster. It becomes more and more steep. It becomes steeper and steeper, right? And this level of detail actually has a lot to do with the concept of differentiation. So now let me just throw two terms out there which are going to describe the concept of a derivative really, really well, and then we'll think about what it actually means, okay? So we already said that in this video we're dealing with the behavior of functions, with the shape of functions. So what does it really mean to look at a derivative of a function? So it's not just for the sake of IB curriculum, it's actually very, very useful to think about derivatives in two separate ways. Number one, and number two. We can say it is to do with the rate of change of something. We don't even need to call it a function. The rate of change of something. So how fast is something changing at a given moment or for a given value of some other thing? So the rate of change, this is more of a conceptual way of thinking about derivatives. The other way is to say that the derivative is basically the value of the gradient of a function. And then we're thinking really visually. We're talking about graphs of functions. We're talking about their steepness at a certain point. So I can say it's more of a geometrical understanding or visual. And I really do want you to think about this in such simple terms, especially at the beginning. So when you hear the word derivative, You just want to imagine in your brain you saying rate of change. How fast or how slowly is something changing? Is it increasing? Then it means the rate of change is positive. Or is it decreasing? Then the rate of change is negative. Or visualize, if you want to think about something in terms of a function, in terms of its graph, visualize the shape and think of the gradient, where the gradient is the same thing as we discussed when talking about straight lines. So the gradient is basically how steep the graph is at a certain point. So you can draw what's called a tangent and say that the tangent has a certain gradient, just like straight line has a certain gradient. So you can see that the tangent here is less steep, so has a smaller gradient than the tangent, say, in here. Let's call it tangent 2. Tangent 1 and tangent 2. Which means that the value of the derivative of the function here, so at x equals, say, 1.3, is larger than the value of the derivative of the function when x equals, say, 0.4, 0.3 as well. Okay, which means that the function changes more quickly here than it does here, which means that the rate of change of the function is greater here than it is here. And that's all these sort of ways of describing the behavior of the function that are really essential in understanding the concept of derivatives. So that's what I'm going to leave you with for now.